Hello everyone, welcome back all of you. In this session we are going to move to our second type of higher order linear differential equations. So in the previous session we had discussion on homogeneous linear differential equations, and now we'll have the look of the solution of non-homogeneous linear differential equations. So in the previous session we had the discussion on f of d into y is equal to 0. So in the left hand side all the terms are going to be multiplication of y, and in the right hand side if it is 0 then we are going to call it as homogeneous linear differential equations. And in that we had the discussion that how we are going to write the solution, like if the roots of our auxiliary equation are real, complex or irrational, or combination of them. And now in this case we'll proceed to our second type of equation. If all the terms left hand side are the multiplication of y, and in the right hand side if we have capital X, that is non-zero, means it is going to be the function of x. And in that case how we are going to write the solution. So in the previous case when capital X is 0, that part we called it as complementary function. I did not tell that before, so I am telling now. That thing whatever we have done till now in the case of homogeneous linear differential equation, that is complementary function. And now in the case of capital X is non-zero, is the function of x, and we are going to write the solution as particular integral. So that part was complementary function and this is going to be particular integral. And in the upcoming sessions we'll mug up both the things, like complementary function and particular integral, and that is that we are going to call it as complete solution. So as of now our main focus is to write the particular integral. So first we'll have the look of what are all the possible cases and how we are going to write the particular integral solution, and in the upcoming session we'll make it complete one. So now let us focus on if our function capital X is capital X is the function of x, and if we have function of x like e power ax plus b or constant, because constant thing also we are going to consider it in this only, because if we put a is equal to 0 and b is equal to 0, so this is nothing but e power 0 plus 0, e power 0, e power 0 is nothing but 1. So whatever the constant, even if we are going to get, that we'll consider it in the first case itself. So what if our function is nothing but e power ax plus b or constant, or sin x plus b or cos x plus b or x to the power m. So this is the fundamental three cases. And if we have the combination of first and second one, like e power ax and sin x plus b, or e power ax and cos x plus b, or the combination of first and third one like e power ax and x power m. And in the fifth case, if it is the combination of second and third case, like x into sin x plus b or x into cos x plus b. And in the last one, in the last case, if we have the function of x, but that function of x is not at all any out of these five, so it is not at all combination of any of them. So in that case we are going to call it as method of variation of parameters. So for that also we are going to have one method, that also we'll discuss in a very detailed manner. So as of now in this session we are going to focus on these five particular types. If we have any five of them, how we are going to write the particular integral part. And in the next session we'll have the look of method of variation of parameters, and then after that we'll have the look of mixing of homogeneous and non-homogeneous, and we'll write the complete solution. So let us start with these five cases. So having said about five different cases, so the first case I told that if the capital X is the function of x, and if it is nothing but e power ax plus b, or if it is a constant. Constant means a and b both are going to be 0. So the constant case also we are going to consider it in this one only. So how we are going to write the particular integral? So we have the non-homogeneous equation of something like f of d into y is equal to capital X, and capital X is nothing but e power x plus b or constant. Constant I am naming as k. So how we are going to write the particular integral? So yp is going to be x upon f of d. So f of d is nothing but all the higher order terms. So the auxiliary equation we used to write in our previous cases as well. So either e power x plus b upon f of d, or if it is a constant, k upon f of d. So to write the particular integral we have to replace this d by a in the f of d. So that we are going to get it as f of a, because if d is replaced by a, so it is nothing but f of a. But we have to keep in mind this f of a should not be equal to 0, because if we have denominator 0 we are going to end up with indeterminate form. So we have to very careful. If we are replacing d by a, the f of a should not be equal to 0. If it is 0, most of the cases it is not going to come as 0, and if it is coming as 0, we have to go one more step further. What we have to do, we will have to multiply the whole thing by x, and this particular f of d will have to differentiate once, so this will become as f dash d, and now we will have to put the value of d as a. So this is going to become as x into e power x plus b divided by f dash a. And also again, when we are putting the value of d as a, we have to make sure that again the f dash a should not be equal to 0. If it is 0, we will have to write like x square e power x plus b upon f double dash d, and then we will have to put f double dash a, and we'll have to check f double dash a should not be equal to 0. So that is going to be little lengthier one, that is not going to happen here. Only up to one differentiation you keep in mind, that if this f of a is not equal to 0, differentiate the denominator once and multiply with x, and then put the value of d as a. So that's how we are going to write the particular integral for case number 1. And also I have taken a few examples, that if our auxiliary equation on the left hand side is nothing but d square plus 4d plus 1, so e power ax plus b, so a is nothing but 2, right? So replace d by a, so this will become as e power 2x plus 3 divided by 2 square plus 4 into 2 plus 1. So this will be e power 2x plus 3 divided by 2 square is nothing but 4, and 4 to the 8, 4 12 plus 1 13. So our answer will be, so the particular integral will be e power 2x plus 3 divided by 13. So this is as simple as that. And in this case, e power 3x minus 4 divided by d minus 1 whole square d plus 2. So again the a is equal to nothing but 3, because we have to do nothing with b, only a we have to take care of. So replace d by 3, 3 minus 1 2 whole square is nothing but 4, and 3 plus 2 is nothing but 5. So e power 3x minus 4 divided by 4 5 is 20. So this is going to be our particular integral. So there is nothing much difficulty in writing the particular integral solutions. And also I have I will give you one general formula if they are willing you to make use of this particular property, like you have to multiply by x and differentiate. This is the standard case we are going to get usually. So that will write as general formula, that if we have the auxiliary equation f of d as d minus a whole power k, so we have to write the particular integral yp is equal to e power ax plus b divided by d minus a whole power k. And if we are making use of rule replace d by a, so if we replace d by a minus a is going to be 0, so that f of a is going to be 0. So here we will have to make use of that differentiation property, that we will have to write yp is equal to multiply by x, write e power x plus b, and differentiate the denominator. So k into d minus a whole power k minus 1, because differentiation of x power n is nothing but n into x power n minus 1. So k will come in the front, d minus a whole power k minus 1. And now again what we have to do, now we have to replace d by a. So again if we replace d by a, this is going to be again denominator 0, so differentiate one more time. So you are going to write d square e power ax plus b, and in the denominator k into k minus 1 this time, and this will become d minus a whole power k minus 2, right? So again if we put d is equal to a, this is going to come as 0. So all the times up to all this differentiation going to come in the denominator, we are going to get the terms 0 and 0. So till what value we are going to get the 0? Up to x power n e power ax plus b, not n, k, because the power is k. So we will have to differentiate k times, and in the denominator we are going to get k factorial, because we are going to get k, k minus 1, k minus 2, and up to 1. So that we can write as k factorial. And to make it more comfortable also, let me tell you one example also. If you have the problem something like f of d is yp is equal to e power 3x divided by x minus 3 and whole power 3, and if you wish to write the particular integral for this thing, how we are going to write directly. So first I will write using the formula. It is going to be nothing but x power 3 e power 3x divided by 3 factorial. So but as I told you the derivation also, let me do it once. So how we are going to do this? This is nothing but e power x plus b form. So we are going to replace d by a. So e power 3x divided by 3 minus 3 whole power 3. But we have to make sure that the denominator should not be 0. So we will have to differentiate it once. So this is nothing but x into e power 3x, and differentiate once. This is going to be 3 into x minus 3 whole square. and again if we put x as 3, sorry, d as 3, I am missing it, d as 3. Again if you replace d as 3, you are going to get 0 in the denominator. So again differentiate one more time, this will be x square, because every time you differentiate you have to multiply with x. So this is nothing but 3 into 2 and d minus 3, and 2 minus 1 is nothing but 1. And now if you again put d as 3, you are again going to get denominator 0, differentiate one more time, x cube e power 3x divided by 3 into 2, and the power is nothing but 1, right? So 1 into differentiation of d minus 3 is nothing but 1. So you are going to get e power x, x power 3, e power 3x divided by 3 into 2 into 1 is nothing but 3 factorial. So that is going to be answer. So instead of doing this much, if the question is like in this particular format, and you can write the direct solution, that x power k, whatever the power of the term in the denominator, so that many times you have to write x to the power k, and this term is as it is, and in the denominator the factorial of that particular power. So now in the second case, if you have the function f of x as the sin ax plus b or cos ax plus b, so again we have the non-homogeneous equation of the form f of d into y is equal to capital X, and the particular integral will be capital X upon f of d. So in the previous case we were replacing d by a, and now here we will have to replace all the d square terms by minus a square. So we called that particular thing as f of d is replaced in f of a, but here we will write it as f of d replaced by some another function of phi of minus a square, and again we will have to make sure that the denominator is by putting d square as minus a square should not be equal to 0. So to understand that, I have taken 3 examples. So in the first case, the particular integral is nothing but sin 2x plus 3 upon d square plus 9. So replace d square by minus a square. So a is nothing but minus 2, so minus of 4, because minus a square is nothing but 2 square 4. So replace sin 2x plus 3 divided by d square by minus 4 plus 9 is nothing but 5. So this is going to be our particular integral. And now in this case we have cos 1 minus x, we have to compare it with ax plus b, so a is nothing but minus 1, and replace d square by minus a square. So minus a square minus 1 square is nothing but 1, so minus 1 will have to replace. So this dq we can write d square into d, so this d square will have to replace by minus 1, so minus d it will become plus 1. And now take this particular thing either in the numerator, or let's divide the numerator and denominator by 1 plus d. This is nothing but rationalization, right? So 1 minus d divided by 1 plus d, because to solve this particular question every time we have to replace d square by minus a square, so we have to get the d square terms first. So this is nothing but 1 plus d into cos 1 minus x divided by 1 plus d into 1 minus d is nothing but 1 minus d square, and replace d square by minus 1. So 1 minus of minus 1 in the denominator, it will become 2, and in the numerator multiply cos 1 minus x with 1 is nothing but cos 1 minus x, and multiply cos 1 minus x with d means we have to differentiate cos. So the differentiation of cos is nothing but minus sign, and due to minus in the x, here is going to come out as minus 1, so minus minus will become plus. So cos 1 minus x plus sin 1 minus x, and in the denominator is 2. So this is going to be our answer of particular integral. So sin 1 minus x plus cos 1 minus x divided by 2. And now in the third case we are going to have the look of differentiation property, that if we are getting the 0 in the denominator, how we are going to make use of for differentiation, because here a is nothing but 3, right? So d square is equal to a square is nothing but 9, and we have to replace d square by minus a square, so minus 9, and if we put minus 9 and plus 9 0, so here we are going to we have to make use of differentiation, that by putting d square by minus a square, if we are getting the 0 in the denominator, we have to differentiate once, multiply the thing by x, and we have to write cos 3x minus 4 divided by differentiate. So differentiation of d square is nothing but 2d, and differentiation of 9 is 0, and now rationalize it and multiply by d. So this will become 2d square, and now place d square by minus 9. So this will become x is out, and differentiation of cos 3x minus 4 and divided by 2 into minus 9, nothing but minus 18. And also keep in mind, if we are rationalizing, you don't have to differentiate this particular term. This you have to keep separate from our calculation, because if we are making use of differentiation property, that x we have to keep aside, because that is not the part of our problem. These things are the part of problem. So if we are taking d in the numerator, we'll have to differentiate only cos 3x minus 4 term, because students do mistake here. They differentiate both by using the addition rule answer. So differentiate only cos 3x minus 4, and differentiation of cos is nothing but minus sign again. So minus sign 3x minus 4 and into 3 term is going to come out, because it is in the multiplication of x. And now minus 18. So minus minus gets cancelled, and 3 6 are 18. So answer will be x into sine 3x minus 4 divided by 6. So that's how you have to deal with the case number 1 or case number 2. And also in the both the cases I have given the format that how we are going to deal with the differentiation. If you are getting the f of d or f phi of minus a square in the denominator as 0. And even in the further cases also, in the by substituting, whatever substitution according to the case is given, if you are getting the denominator as 0, you have to make use of differentiation property all the time. So let us discuss our 3 more cases. And now in the case number 3, if f of d into y is equal to x power m, so that capital X is nothing but the function of x. And always keep in mind, this m should be only positive value, like x power 2, x power 3, or you can have polynomial, right, 4x square plus 3x plus 2, something like that. This m should not be negative 1. So how we are going to deal with that? The particular integral we are going to write as x power m divided by f of d. And here in this case there is no technique like replacing in the previous 2 cases. Only what we have to do, this f of d we have to take in the numerator, so that is going to become as whole inverse, and that will have to expand using binomial expansion. And those differentiation terms, whatever after expansion we are going to get, we have to apply on the x power m. So to do that, we must have the idea about the basic binomial expansions. So I have written 4 basic of them. So most probably we are going to encounter these only. So 1 minus x whole inverse is nothing but 1 plus x square plus x cube. 1 plus x whole inverse is nothing but 1 minus x plus x square minus x cube, and also 1 minus x whole power minus 2, or 1 plus x whole power minus 2. So make note of them, you have to use them. So to solve the problem, I have taken the example also, d2y by dx2 plus 2y is equal to x square plus 2, and it is being asked in the question that calculate the particular integral of this particular differential equation. So what we are going to do, we have to replace d by dx as capital D. So this is nothing but d square y plus 2y is equal to x square plus 2. So d square plus 2 into y is equal to x square plus 2. So now this is in this form, f of d into y is equal to x power m. So this is coming as polynomial. So what we have to do now, we have to write this f of t first. So we have y is equal to x square plus 2 divided by d square plus 2. So this f of d we have to take in the numerator and have to write like inverse, d square plus 2 whole inverse, and we have x square plus 2 in the multiplication. And this is nothing but if we assume this d square term as x, or first we'll have to take 2 outside, right? So then only this will become something like 1 plus. So before writing this, we take 2 outside here itself, and if we take 2 out, this will be d square by 2, and this is nothing but 1. So we have 1 by 2 and 1 plus d square by 2 whole inverse now. So now we can make use of our binomial expansion, 1 plus x inverse, and other things I'll rub. Okay, this was the question. Okay, Robert, solid. Fine. So now apply the binomial expansion first. So this is nothing but 1 plus x whole inverse. So 1 minus x d square by 2 plus x square. So x square is nothing but d power 4 by 4, because square of d square by 2 is d power 4 by 4. And minus, but all the terms we can neglect because we have x square term only. So we are going to make use of only differentiation up to 2. So by p is nothing but 1 by 2 plus multiply this x square plus 2 with 1 is nothing but x square plus 2 minus 1 by 2 and d square. So differentiation of x square plus 2 times. So differentiation of x square plus 2 once is 2x and one more time it is 2. So we are going to get 2, and all the higher order differentiation we are going to get the differentiation 0 only. So we are going to get the particular integral as y2 is equal to 1 by 2 x square plus 2 minus 1. So this will be 1 by 2 x square plus 1. So that is going to be our answer. So this is the next case. The fourth case, we have our capital X is nothing but e power ax into sin ax plus b or cos x plus b or x power m. So we have the combination of case number 1 e power x plus b and case number 2 like sin x plus b cos x plus b, and also case number 3 is also included x power m. So if we have something like that, how we have to do? The thing you have to keep in mind that if e power x term is there with second or third cases, first you separate this e power x term. To do that, you have to replace this d by d plus a. So this is going to be nothing but e power ax will be left over, and this will become as v upon f of d plus a. And now if we have this case sin x plus b or cos x plus b, we'll have to make use of substitution like second case, and if it is x power m, we'll have to do the procedure like binomial expansion as in the third case. So only after doing d by d plus a, we are going to end up with case number 2 or case number 3. So to do that, I have taken the example of both of them. So the first example is nothing but d square minus 2d plus 5 into y is equal to e power x into cos 3x. So the yp is nothing but e power x cos 3x divided by d square minus 2d plus 5. So this is the this case e power x and sin x plus b or cos x plus b. So what we have to do? First we have to separate it e power x. So a is nothing but 1. So replace d by d plus a. So d plus 1. So write yp is equal to e power x separate cos 3x divided by d plus 1 whole square minus 2 times d plus 1 plus 5. So expand this, d plus 1 whole square is nothing but d square plus 1 plus 2d minus 2d minus 2 plus 5. So 2d minus 2d gets cancelled. This will be d square plus 1 minus 2 minus 1 plus 4 is 5 plus 5 is 4. So this will become as yp is equal to e power x and cos 3x divided by d square plus 4. And now this is nothing but case number 2. We have cos ax plus b. So what we have to do? Replace d square by minus a square. So a is nothing but 3. So minus 9. So e power x cos 3x divided by d square is minus 9 plus 4 is nothing but 5. So that this is going to be our answer. So only additional thing what you have to do, separate this e power x term. To do that, replace d by d plus 1 and you are going to end up with the case number 2. And in the problem number 2, you are going to end up with the case number 3 like the binomial expansion one. So the problem is d square plus 2d plus 1 into y is equal to e power minus x into x square, right? So yp is nothing but e power minus x into x square divided by d square plus 2d plus 1. So replace d by d plus 1. So d plus a. So a is nothing but minus 1 here. So replace d by d minus 1. So you are going to get yp is equal to e power minus x. So e power x term we are going to left. So this will be x square divided by d minus 1 whole square plus 2 times d minus 1 plus 1. So what we have to do? To separate the e power x term, we have to replace d by d plus a. So a is nothing but minus 1. So this is d minus 1. So now you have to solve this. D square plus 1 minus 2d plus 2d minus 2 plus 1. So minus 2d gets cancelled. So this will be d square plus 1 is 2 minus 2. So we are going to have only d square. So by simplifying this, you are going to get d square, and this is now f of d. So what you have to do? You have to if it is like other polynomial like d square plus 2d plus 1, so you have to do the f of d inverse, apply binomial expansion, and then you will have to solve. But in this case, this is coming little simpler one. So only we'll have to integrate, because if we have d into x square, that means we have to differentiate x square. But if you have x square by d, this means you have to integrate. So we have x square by d square, means we have to integrate x square 2 times. So integrate once, we are going to get yp is equal to e power minus x. Integration of x square is x cube by 3, and 1 d is left. And now you will have to integrate one more time. So this 3 you take out, and integration of x cube is nothing but x power 4 by 4. So your answer will be x power 4 e power minus x divided by 12. So that's how you have to make use of this particular case, because this is not at all new one. This is the combination of 1 with 2 or 1 with 3. So in that case you have to separate the case number 1, replace d by d plus a, and then you are going to left with either case number 2 or case number 3. And now we have our last case, that also we'll discuss. And the final case, fifth one, it is going to be the combination of case number 2 and case number 3, because the case number 4 was the combination of 1 or 2 or 1 or 3. So this is going to be the combination of 2 and 3. So we have something like x into sin x plus b or x into cos x plus b. So this sin x plus b or cos x plus b I am naming as v. So how we are going to write the particular integral? Yp is equal to x into v divided by f of d. So first we have to take f of d in the denominator, and here we have one particular formula that we'll have to keep in mind, that we'll have to write the solution as x into v upon f of d minus f dash d upon f of d whole square into v, or if we take v by f of d common, so only x will be left here, and here f dash d divided by f of d will be left here. And once applying this particular format, we'll have to replace d square by minus a square, because this is nothing but sin x plus b and cos x plus b terms present over here, and in that case we replace d square by minus a square. To understand that, I have taken one example also. So this is nothing but d square plus 4 into y is equal to x sin x. So yp is going to be x sin x divided by d square plus 4. So this is nothing but the combination of second case and third case. So in that case, apply this particular format. You will have to write yp is equal to x into v upon f of d. V is nothing but sin x. V upon f of d as it is d square plus 4 minus f dash d, differentiate this. This is nothing but 2d divided by f of d whole square. So d square plus 4 whole square and into v. V is nothing but again sin x. So yp, and now you have to replace d square by minus a square. A is nothing but sin ax plus b. A is 1. So minus a square is nothing but 1. So d square you have to replace by minus 1. So this will be x sin x divided by d square is minus 1 plus 4 is nothing but 3 minus 2d divided by d square by minus 1. So minus 1 plus 4 3 whole square is nothing but 9 sin x, and this 1 d is left, and if we have d in multiplication, we have to differentiate it, right? And also I told we have to differentiate only the sin x plus b term. So yp is going to be x sin x divided by 3. This is independent of d, there is no d term over there, and 2 by 9, and differentiation of sin is nothing but cos x. So this is going to be our answer. So this is as simple as that. Only keep the formats in mind, and you can write all the solutions, either it is case 1, 2, 3 or combination of 1, 2 or 3. So that's how we have to write it, and let us summarize in fast manner whatever we have discussed till now. So in the first case, capital X was the function of x, and it was nothing but e power ax plus b or constant. So that we are going to replace d by a, right? So that's how we are going to do, and we have to keep in our mind that f of a should not be equal to 0. If it is becoming 0, we have to make use of differentiation property. And in the second case, f of x is nothing but sin ax plus b or cos ax plus b. So in that case, you will have to replace d square by minus a square, and again you have to keep in mind that phi of minus a square should not be 0. If it is 0, you will have to make use of differentiation property. And in the case third, f of x is nothing but x power m, where m has to be only positive numbers. So or x power m, it is nothing but denoting the polynomial. We can have polynomials also, but power of m should be positive only. And in that case, what we have to do, that f of d we have to take in the numerator, we have to expand it using the binomial expansion and apply the expansion, those differentiation terms on the polynomial. So up to what term we are going to get differentiation, that we'll have to do. And in the fourth case, it is going to be the combination of 1 or 2, 1 and 2, like e power ax into sin ax plus b or cos x plus b or combination of 1 and 3. So e power ax into x power m. So in that case what we have to do, to take e power x term out, we have to replace d by d plus a, and then the leftover term, if we are denoting these as v, so the leftover term v upon f of d will be left, not f of d, f of d plus a will be left. So this is going to be another polynomial in D, and that we are going to treat as f of d, and then we are going to apply the rules of case number 2 or case number 3, like replacing by d square by minus a square on making use of binomial expansion. And in the fifth case, f of x is the combination of case number 2 and 3, but in the case number 3 it is not it is not going to have the powers, only x is there. So x is with sin ax plus b or cos ax plus b. So in that case, to write yp is equal to x into v upon f of d, you will have to write something like x into v upon f of d minus f dash d divided by f of d whole square into v. And as it is the case of sin x plus b or cos x plus b, so applying this formula at the end, you will have to replace d square by minus a square. So that's how you have to deal with these cases. And in the upcoming session, we are going to have the discussion like if this capital X is not at all any case out of all these 5. So that is going to be known as method of variation of parameter. And also as of now we are discussing the higher order linear differential equation with constant coefficients. So we'll take one example where the constants are not going to be the coefficients are not going to be the constant ones. And after that we'll mug up homogeneous and non-homogeneous, and we'll write the complementary function as well as particular integral, and that we are going to call as complete solution. So with that we will end up with higher order linear differential equations. So that is all for this particular session. If you have any doubt, you are free to ask in the comment section. Thank you.